Hey guys, so I'm back with another logic board repair video today to show you one of my least favorite repairs. The issue this one is having is it's not charging the battery. Let me show you if I can show you the screen here. Can you see that? Let's see. See how there's an X over the battery icon here? That means it's not showing the battery. In fact, I'll go up here and show you what it says. It says no battery available. However, the battery is plugged in. So it's simply not registering the battery like it's supposed to. So the issue is, it could be a couple different things. And this is kind of fun to do. Hopefully it's the easier side of the problem, because if it's not, it's going to be the SMC, which is not fun, and I'll show you the reason why if we get to that. Well, I'll go ahead and explain it to you. If it's the SMC, we can't order the replacement chips. We have to pull them from a board of the same kind. Here's the SMC right here, and that's a BGA chip, and it has quite a few solder balls underneath it. Let me look it up and see how many it does have. So this is your chip, and this is all one chip. It's just showing it, it's breaking up into sections. So here's all the solder balls that are underneath it. This is all these points right here are points underneath the chip. So in doing this, you have to take off this chip, and then you have to put new solder on the pads underneath it, which makes it not a fun thing. The thing about this too is if you replace this, you reball it, and you put it onto the board, then you're facing the challenge of, is this even a good chip? It's possible that you're pulling this chip and it's not even good. And this is one of the problems with right now. We can't order these parts from Apple. Apple doesn't supply these parts to third-party companies that do these repairs. And if you order this chip online, it's still no good because this is a programmable chip, and only Apple can program these. So you have to pull these from a board, a donor board, and use them that way. So hopefully it's not going to be that. Hopefully it's going to be something easy. But I'll show you what we can measure out here. Get my multimeter over here so you can see. And so we're going to measure voltage on these current sensors next to the P-bus chip. Here's our P-bus chip, and we're going to measure it, and I'll show you what we're getting, and I'll explain to you what we're supposed to be getting. So we put our black probe on ground, red probe on one of the test points. We're getting 16.5, which is good. That's what we're supposed to be getting. Over here, you're getting 12.26, which is supposed to be 12.56. So this is low. This up here, that's a good voltage reading. It's supposed to be around that. So hopefully we're just looking at a bad P-bus chip, which would be a lot simpler than replacing the SMC. So what we're going to do is we're going to go ahead and power off the machine. I'll show you another symptom it's having. So you unplug this, and when you unplug the power, typically what's going to happen is it's going to turn right off immediately. But notice what happens. See how the screen dimmed? The fans are still spinning. So something's going on weird here. And it's possible, what happens is this P-bus chip actually communicates with the SMC, which is your system management controller. And if your P-bus chip is not communicating properly with the SMC, then you're going to have problems with the battery being recognized. If your SMC is the problem and not communicating with your P-bus chip, you're going to have the same symptoms. So it's going to be either one of the two. It's going to either be the P-bus chip or the SMC in this situation. And so first of all, we're just going to go ahead and replace the P-bus chip and hope that that's the problem. So I'll show you under the microscope. If I can get it in focus here, that's focused for me. Let me get it focused for you. There we go. So that's our P-bus chip there. That chip right there. And we're going to replace that. We're going to pull this chip off of a donor board as well, because we have plenty of these. So I'm going to add some flux first of all. And removing this, it keeps the solder joints nice. And it does help it come off a lot easier. Waiting for those solder joints to melt, and they'll turn shiny when they're melted and ready to pull. See how this is shiny over here? You see that? So this is ready to remove. So we're going to replace the solder with some leaded solder. Just the pads. We're going to keep that ground pad the same. Or just the external pads here. Alright. So it's still out of focus a little bit. It's a little bit better for you. Alright. Remove the old one from our donor board, or remove the new one, I guess you would call it. The replacement. Alright, and put it in place here. You see how it kind of moves back in place? That's a cool thing about when you put flux on the board or on the pads and you're soldering a chip like this. Check it out again. I can move that chip and it floats right back into place because the solder's connecting to the pads on the board and the chip, keeping it in place. Now we're going to fix the joints up. Add some more flux. Point the tip of this iron down in there, touch the pads, nice and gently. Like that. Still see. Alright, I'm going to turn the board so I can solder the other side. I am not left-handed. Okay. All the pads look good. And now, let's see if we get any change in this. Before, the MagSafe light wasn't even lighting up green or orange. It was only turning green, which shows that it was not charging. So let's see if we get any change. Green. And will it turn orange? It's not looking like it. Not looking like it. Still green. Just in case, I'm going to hook up another battery. And we'll see if this turns orange. Still no orange. So we're looking at a bad SMC most likely. Unplug everything. You'll get to see why this is not a fun repair. Aren't you excited? Well, that's funny looking. This is supposed to be black, but it's not. Anyways, here's our SMC chip again. So what we're going to do is go ahead and remove that from the board, and I'll show you all the contacts underneath. So this is going to be our bad SMC. Alright, let me give you a better view here. Okay. I'm going to move this so I can work on it, actually. So, that's about all you can see there. That's our SMC. In focus for you. Alright, so we're going to go ahead and remove that. Add some flux. I'll just add it to this side since I'm pointing the hot air that way. And it's going to flow underneath the chip. Like that. Again, we're not pointing it that way, we're pointing it this way, because right up there is a BGA chip you do not want to mess up. There you go, you see the chip moving around, floating, ready to remove. I'll mess that chip up, that's alright. So there's all the solder pads underneath. So now we're going to go ahead and clean this board up and get it ready for a new one. Add some flux. Add some fresh leaded solder. Let the solder iron heat up. Let it go deep. Add some fresh leaded solder to the board. And now we're going to use our solder braid to remove all that solder from the board. Now those pads are nice and clean. Alright, now the board's ready for the chip. But now, the fun part. We'll put that board over there, get our replacement SMC off of this board, which we hope is good, and we will reball it, and I'll show you that process. So we're going to remove it first, like we did the other one. Oops, sorry. We're going to add some flux. Okay. Take a look at it. That chip looks pretty nice. clean that chip up and reball it. Let's take a look at our bad chip. I don't particularly see anything wrong with this chip. And that's the thing about it, is that sometimes you can't because it's internally damaged. So all we can do is just try. Put that chip up there. Alright, so this is our donor board. Move that over there. And now, what we do is I have this thing that holds the chip in place. I've already got it sized for SMCs. See, it holds the chip like that. Right inside there for me. Can you see that pretty good? Yeah. Okay. So we're going to clean this up. We're going to use some of our liquid flux that I told you about before. I'm going to clean that tip up. That's pretty nasty. Put some of this liquid flux on it. This cleans all the oxidation off the chip really well. I'm going to add some fresh solder, leaded solder to our chip. Okay. Clean the chip up. Alright, so now we have to get our stencil. And this is the stencil that I have. It's not the exact same kind. So what we're going to do we're going to tape this down to the top of the chip. See how everything lines up underneath. But those few holes in the middle, there's nothing there. This is designed for another SMC, but we're going to use it anyways because I don't have this specific one. So we'll get some of our Captain tape. Cut off a nice size of it. And I'm going to go right on top of that. Keeping it lined up. Tape it down. Cut off another one. And I'm going to go right down the other way. Just like that. So now, that's going to keep that in place while we add new solder balls to this chip. I'm going to get my X-Acto knife out. With a new blade. And what I'm going to do first is I'm going to cut along here because I don't want to get solder in those holes if I don't have to. I really just need to get me a stencil for this specific chip. It would be much easier. Okay. Alright, so hopefully that stays. And then we're going to cut out around the chip. So we're going to lift that up. Hopefully the middle section stays down. Not too bad. Alright, so that's what we have. Now we're going to get some of our Kester solder paste. Got a whole tub of it here. Get some on this flat tool. Gently put it in. This is some pretty cool stuff because this is, I don't know if you can see it, but there's tiny solder balls inside this paste. Alright, so we got it on there, and now we're going to gently wipe it off with a dry cloth. You stay down. And that tape doesn't have to necessarily stay on there, it's just to keep the solder balls out of those holes. Alright, so we're going to go ahead and remove this now. I guess it's the best thing to do. And then wipe the rest of it down. Okay. And now we're going to turn our air down fairly low because we don't want to blow all these solder balls out. Let me go ahead and show you how small see if you can see that. You see inside those holes? See all those solder balls? This stuff is super tiny. Got some small solder balls there, and it's in this flux paste. So what happens is, and we're talking about tiny stuff. What happens is when you melt this down now, it's going to form bigger solder balls, and it's going to fill those holes, and those pads should have solder balls on them then. So again, let's go ahead and heat this up nice and slow. Focus. And we'll gently raise the speed as we go. We just want to start the melting first. So you see the flux heating up and bubbling. Now if we had the airspeed on really high, it would blow the solder balls right out of the stencil here. And we would have to start over. You can see some of them starting to melt. And that's what's supposed to happen, as long as they all stay in their place. So far, so good. Oh, that worked a lot better than I was hoping. Alright, now we can remove the tape. And then I'm going to drop this right into my ultrasonic cleaner, and it'll loosen up the chip, and then we'll get the chip off. So now I'm going to gently pry this off. Not that I have to add any force to it, it's just to make it fall off, like that. And now we have solder balls on the chip, the replacement chip. So we're going to clean that up. Just got a toothbrush and some alcohol. We want to get all the flux out of there that we can. Don't want to get any extra flux. Alright, here we have our chip. Hairs in there, get those out. Alright, looks pretty good. All the solder balls look even, and looks like we're good to go to put this on the board now. Get our board back over here. And we want to prepare the board with some fresh flux. Alright, I'm going to use my finger, evenly coat this. Okay, it looks clean. Looks like flux is on there pretty evenly, making sure there's no hairs. Yeah, you're good. Let me wash my hands real quick. Right, now we're going to put the chip on, and you see here, the way it's designed, there's a ball, or there's a pad here. None in this corner, none in this corner, none in this corner, pad there. So we're going to match that up here with our chip. You can see how it's the same way. It has a pad right there in the corner. So it goes in that top right corner like that. And now the fun part. Use these tweezers. So we're going to place this on here. And there's no outline of the chip, so you have to eyeball it. And it's about right there. So I'm going to heat this up now. Raise the air up full force. Make sure I got it still. Got it right there. Now I'm going to hold it in place while I'm heating it. Reposition because that's really hot. We're gonna add a little more flux. Chip. Since it's hot, it's going to melt right underneath that chip. You can see how the chip's already kind of melting in place because I can't move it now. So now we're just going to hold the hot air station back a little bit, heat the board, and slowly get closer to melt the chip in place. If I get close really fast, it's going to make that chip fly right off, and then we'll have to start all over again. I'll have to reball the chip and all that fun stuff. Starting to move into place. Alright, now it's moving around. See how I can touch it and it moves back. Very good. Let that cool down, and then we'll give it a try. Alright, now we're going to install the board. Install the board back into the machine here. Plug in our MagSafe. Plug everything back in. I'm not going to put any screws in because, hey, what if I have to take it back out? I don't want to have to unscrew everything again. Plug in our battery. And let's get our adapter. See what happens. Got a green light. And we have an orange light. What do you know? So we're going to boot it up into our test drive and make sure we have a charging battery now. And here we go, back on our screen again. We have 94% and a charging symbol. So it is recognizing the battery now. Let's try unplugging the power adapter and see if it stays on. It stays on. And we have 94%. We have a charging battery now. The battery's being recognized. Okay, now we're going to go over to the schematics and I'll show you why this is so. So here we have our schematics for this board, and we want to look at the SM bus connections right here on page 47. I'm going to go down to 47. Alright, so up here you see SMC battery, your SM bus connections. This is your system management bus connections. So and bus means it's pretty much the data line. It's going to be a connection between two different parts of the board that are talking with each other. And so here you see the SMC chip, the U4900, is talking to the battery charger, and it's talking to the battery. The battery charger is that P-bus chip that we replaced first. And you see here it says read and write. Whoa, read and write there. So this is a bi-directional data line, which means the SMC talks to the charger chip talks to the SMC. And the same thing with the battery. Over here you see the battery manager, the LED driver, the battery temp. There's read and write. This is bi-directional as well. So your SMC is talking to the battery, and the battery is talking to the SMC. If the battery is not being recognized, then you're probably going to have either a problem with your P-bus chip, this battery charger chip, or the SMC. In this case, it ended up being the SMC, and we were able to fix it, fortunately, on the first try. We ended up getting a good SMC chip. That doesn't always happen. So that's why this repair is not my favorite. So now we have repaired that, and it's exciting to get to show you that. It is a common repair that we do here at PowerBook Medic. A lot of times it ends up being the P-bus chip. A lot of times it ends up being the SMC. Just requires some diagnosing, some testing, and fortunately we have plenty of these parts here, plenty of donor boards that we can use to get the board up and running. So hope you learned something. If you have this problem, be sure and go to our website, which I can show you real quick. PowerBookMeta.com. At the top where it says send and repair, just go down to MacBook Logic Board Repair, and here you'll have two options: Logic Board Only Repair, where you send in just the Logic Board only, or if you don't want to take out the board and send us that, send the complete unit in. It's wise to send the complete unit in because a lot of times it may look like a Logic Board repair, ends up being something else with the board, or the machine, so it's wise to send the complete unit in. It does cost an extra $95 labor, but it is worth it, believe me. Otherwise, we get your board in, your board's working fine, and we have to end up getting the rest of your machine in anyways because it's not the board. So definitely feel free to click on this, schedule a unit repair, and get us the board so that we can get it fixed up for you. Like I said, hope you learned something. Hope you have a great day.